So in this video, what we're going to do is start with a linear equation that is in standard form, and we're going to convert it into slope-intercept form before graphing it. So the directions say put the following linear function into slope-intercept form and use that form to graph it. So this is actually a linear function that we've already graphed in an earlier video. It's in standard form because it has the form it's in the form ax plus by equals c, in the sense that this is the b times y plus this is the ax equals, and here's the c. So it's in standard form. And the way that we graphed this in the previous videos, we found the x and the y intercepts, we plotted them, and then we drew the line through the x and the y intercepts. This time we're going to take a different approach. What we're going to do is put the function into slope-intercept form and then use what we learned about how to graph functions in slope-intercept form to graph this function. So I start with my function 3y plus 2x equals 12, and it says put it in slope-intercept form. So I need to put it in the form f of x equals mx plus b. And we want to remember that when we have a function, that y and f of x are the same thing. So we're really saying, hey, solve this function for y. Put this function here that's in standard form into the form y equals mx plus b. Solve it for f of x. Solve it for y. So we're going to do that. So I need to get the y by itself. So I'm going to start by subtracting the 2x from both sides. So if I subtract the 2x from both sides, I'll have a negative 2x plus a 12, because this 12 is positive, which means it's being added on the right-hand side. And that will leave me with a 3y on the left-hand side. And then we'll sweep through. I'll divide everything on the left by 3, which means I need to divide everything on the right by 3 as well. Whatever I do to one side, I do to the other side. So everything over here was divided by 3, which means everything over here must also be divided by 3, and now I have the function y equals negative 2/3 x plus 4, and this is definitely in the form mx plus b, where m is equal to negative 2/3, or the coefficient on the input variable, and the b is equal to 4. So the b equaling 4 tells me that the y-intercept is at positive 4. And the negative 2/3 tells me that I have a rise of negative 2, so the function's dropping downhill, and I have a run in the positive x direction of 3 units. So I want to move to the y-intercept, which is a point I know is on the graph, and then I want to go down 2, and then 3 to the right. So we'll move down 2 towards negative infinity, and then 3 to the right towards positive infinity relative to the x-axis. And then we step in and we get a ruler out and we draw the very straight line through those 2 points. We pretend that went through that point. I'm not going to rewrite that line because it's about as straight as I can draw it. So we want to label our points. So this is the point input 0, output 4. That's our y-intercept. This point right here is the point input 3, output 2. We want to make sure that our number lines have arrows on them. We want to make sure that our x and our y, or f of x, axes are labeled. That is bugging me a little bit. Isn't that sad? I'm going to try one more time. I'll probably make it worse than it was. That's what happens when you try something again. You just make it worse. There we go. It's better. It's better. It's almost going through that point now. So that's how you do it. You just solve it for y so that it's in the mx plus b form. Solve for y, and then use the slope and the y-intercept to draw the graph.